So that is what we have shown in the first pulse. So this is where my first rectangular pulse starts. So this is my first rectangular pulse. You can see capacitor will charge to this first point, and then as modulating signal changes, the capacitor voltage will also change. And as the pulse is gone, now when the sampling pulse will be over, in that case sampling switch will suddenly be off. Now once it is off, the capacitor voltage cannot follow the modulating signal anymore. The moment sampling pulse is off, we have to enable G2. We have to turn on the discharge switch, because the moment discharge switch is on, the voltage across capacitor will come down to zero quickly. So what will you record across the capacitor? You will record a sudden increase in the voltage and then change in voltage as per the modulating signal, and sudden decrease in the voltage. So this is because first G1 is enabled, that means sampling switch is enabled, and then discharge switch is enabled. The moment discharge switch is enabled, the voltage across capacitor comes down to zero. Now if you want, you can keep the discharge switch on, because we don't want capacitor to charge until the second sampling pulse arrives. So when the second sampling pulse arrives, it is at that time instant discharge switch should turn off, and because there is a sampling pulse, sampling switch will also turn on, and modulating signal will be now given to capacitor once again. So once again capacitor will charge to this new value of the modulating signal. Sampling switch will remain on as long as sampling pulse is available. Capacitor voltage will change accordingly. The moment sampling pulse is over, there will be a signal which will enable the discharge switch, and the discharge switch will make capacitor discharge to zero quickly. And this will keep on happening, and you can see we will obtain various rectangular pulses across the capacitor, or across the output we can say, and all this will be nothing but representing the pulse amplitude modulated waveform. So whenever modulating signal amplitude becomes negative, you can see capacitor will charge to negative voltages, so my output will also be negative in that case. Let me call this as output VOT. Alright, so my output VOT will be nothing but PAM signal, pulse amplitude modulated signal, which we obtain as per the charging and discharging. Now if you observe carefully, whenever sampling switch is on, discharge should be off, and whenever sampling switch is off, we have to turn on the discharge switch. And hence the signal that should enable the discharge switch should be exactly opposite of the first signal, and hence whatever signal we are giving to sampling switch, we can invert that signal using inverter and give it to the discharge switch, so that both sampling and discharge switch will operate in proper unison. So that's your first modulation technique using pulses in the form of carrier. As you can see that the information is present in the amplitude of the pulses. So after the modulation is over, the width of the pulse is still exactly same as what it was before, tau, and the rate at which the pulses are occurring is also exactly same. Then what is changed in this case is the amplitude of each and every pulse. That is changed, and hence it is called pulse amplitude modulation. So having discussed that, let us now see how I can obtain my original modulating signal back from the PAM signal. Please note that if you just look at the amplitude of rectangular pulses that we have obtained, the shape of the amplitudes of rectangular pulses will resemble to my original modulating signal, and hence it is something, this property that we will use in the demodulation process.